Welcome back, students. Today we're going to be talking about family functions and transformations. So a family function is going to be any grouping of functions that all have a specific trait to them. And the parent of that function is going to be the most basic form of that. So we're going to take a look at different families. We're going to look at what the parent looks like. And then we're going to see what traits we're looking for within those families. And we'll go from there. So let's take a look at this. Right now, we've got 4 families that we're going to be looking at today. So first, the constant family. Now, its parent or rule is going to look like f of x is equal to 1. Just f of x is equal to some constant number. There is no x value, and this creates horizontal lines. Okay, horizontal lines are all going to be examples of the constant family function. The domain is going to be all real numbers because x can be any number in this. The range is going to be limited, though, to whatever the value of the constant was, in this case, 1. All right, let's look at the linear family of functions. Its parent function is f of x is equal to x. These form diagonal lines. The domain, x can be any real number. The range also can be any real number. X and y can be any numbers. The absolute value family function. Its parent or rule is going to be f of x is equal to absolute value of x. We notice that the absolute value family forms these V-shaped functions where the domain, x can be any real number. The range is limited, though. Notice how we never go below 0 in y, so the y has to be greater than 0. Then we've got the quadratic family function. Its parent or rule is going to be f of x is equal to x squared. Notice this, rather than forming a V, forms more of a U. You can also call this shape a parabola. The x values can be all real numbers, but once again, notice it never goes below 0. Our range, y has to be greater than 0. All right, so let's look at this first example. We want to identify what the function family this belongs to. Then we want to compare it to the parent function. All right, well, I'm going to go ahead and graph the parent function right on here for us. So by, let's see, all right. So there's our parent function, and we want to see how things have changed with this. So we notice, first thing I notice is that kind of center point, the tip of the V. Notice that it's about 1 up. Also, look at our equation with a +1. It looks like this has been moved. Well, actually, let's start with the first thing it asked us to do. Identify the family. So this is a V. This is going to fit into the absolute value. We also look at the equation. We've got the absolute value of x inside of there. So the family it belongs to is the absolute value family. Let's talk about the comparisons. So notice right there that the tip of the V, it's been moved up 1. So that's the transformation that has happened to this. Now, usually shifts that move us up, down, left, right by a specific amount, we call those types of transformations a translation. So this was a translation up 1 place. But there's more than just that, because if I tried to grab that part of it, let's even see if we can grab some more of it. Okay, so if I tried to grab it and move it up one, notice that's not the only thing that's changed. The slant of those lines are now steeper. So let's look at what's happened with the slope. Before, it went over one, up one, over one, up one, over one, up one. This is now going over one, up two, over one, up two, over one, up two. It's going up twice as fast as it used to. Now, we refer to this as a vertical stretch. And hopefully you can see why. The way that it is more stretched out vertically, it's pulled vertically. And we would say that it is stretched by a factor of 2. Okay? Because it's going twice as much. All right. This next one. So we're going to graph and describe another translation. So we've got this graph of g of x is equal to x minus 4 and its parent function. So here's the parent function. F of x is equal to x, graphed right there. And the parent and the other function g of x, x minus 4, is graphed right there. And we want to now describe the transformation that has happened. Now, one thing I am noticing is at this point, so from there to there, it went down 4. From there to there, down 4. From there to there, down 4. It seems like at every point on the parent function, the child function is exactly 4 below, which would make sense because we subtracted 4. So we've got our graph, and we can visually see that the transformation, remember that when we do a shift in one direction, that is called a translation. In this case, the direction was down 4 places. All right, now we're going to graph p of x and its parent function, and then describe the transformation. Well, let's look at what kind of function we're dealing with here. We've got an x squared, which is going to be quadratic. Now, ours was negative x squared. This is positive x squared. So I'm going to create, in order to graph this, one for the parent and one for p of x. So we're going to have xy. And in fact, let's kind of simplify that. So our y values are essentially coming from just x squared. Okay, that's what our y is equal to. So if I have negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, and so on. For p of x, we have our x, we have our y. Remember that our y here is determined by negative x squared. Okay, so as I fill out my numbers for x, so negative 2 squared would be 4, but then we got the negative in front of it, which would change it to negative 4, negative 1, 0, negative 1, negative 4. All right, so let's graph the parent it's going to look a bit like that. P of x, we'll do that in red. All right, so we want to describe what's happened here. Well, notice how the top looks pretty much just like the bottom. Everything just got flipped around. Now that flipping, or if we folded this along the x-axis, the two equations would be touching. This flipping is called a reflection. So this is a reflection. Now, when you state that something is a reflection, you should state over what line did it reflect. So that would be, in this case, reflection over the x-axis. All right, so let's do two more of these. Graph each function and its parent function. So we've got 2 times absolute value of x. So this is an absolute value family function. Let me go ahead and draw the parent first, which just x is equal to y, and it just forms this up 1, forward 1 pattern. Okay, so there's our parent. Let's now do this. Notice that multiplication of 2. We've seen what that does before. It changed the slope of this so that when x is a 1, it actually goes up by 2. And you can do this if you're not quite sure what points you're supposed to go through, make a table. Okay, so we found it. Now we're going to describe that transformation. Notice when the black one was at 1, this one was up at 2. When the black one was at 2, this was up at 4. When the black one was at 3, this one was up at 6. Everything is twice as high. This is a vertical stretch by a factor of 2. All right, next we've got this x squared. This is a quadratic family function. We just graphed one of those in the previous. So 0, 0, 1, 1, 2, 4, 3, 9. Okay, we're just squaring each of those values. Let's draw our curve. All right, so there's the parent function. Now let's think about what would happen with this. So notice the x squared is still there, but we're multiplying it by a half. So we're going to have half of any value that was there. Well, half of 0 is still going to be 0. Half of a 1 would be a 1. Half of the 4 would be at 2. Half of 9 would be at 4.5. Let's see, 4 would be 16. Half of that would then be 8. Then we're going to get those same values here. All right, so rather than stretching it vertically, by multiplying by a half, we did a compression. Some people will also refer to this as a shrink. Either way of saying it, is fine, but because we used the word stretch, I like to go ahead and use compression for this. So vertical compression by a factor of 1/2. Everything is half as high as it used to be because of that multiplication. All right, I hope this helps you. This is part 1 of parent function and transformations. Good luck.